All right, let's just get straight into the weeds on infrastructure today.
Yeah, we were looking at a very specific piece of gear for this deep dive.
Exactly. We've got the Kramer CLS-AOCH 6197. It is a high-end active optical HDMI cable. And to be totally upfront with you, our mission today is to figure out why on earth a cable costs over $500.
Right. I mean, the sticker shock is completely real. It lists for around 700, though the street price is hovering around 560.
Yeah, but if you are in the AV game, you know that at this length, you aren't really paying for a cable.
No, you're paying for an insurance policy.
Exactly.
Because we are talking about a 60-meter run here. That is 197 feet. If you're a professional integrator, the cost of the cable is negligible compared to the cost of
Having to roll a truck back out to a site 3 months later.
Exactly, just because a cheap copper run started dropping the signal.
Because physics just gets in the way.
Yeah.
Once you push standard copper HDMI past maybe 10 or 15 meters, capacitance and resistance just start killing your high-frequency data.
You get sparkles on the display, handshake issues, or just the dreaded black screen.
Yeah, and usually the fix is adding clunky hardware, HD basic extenders, external power supplies, balloons hidden behind the TV.
Right, which just adds more points of failure. The mission of this Kramer unit is to eliminate those boxes entirely. It uses active optical technology.
Right, it's a hybrid design.
Yeah, meaning it uses 4 optical fibers to carry the high-speed video data, but it actually keeps standard copper wires for the low-speed signaling.
Like your ED and HDCP handshakes.
Precisely.
Which is such a smart approach. You get the massive bandwidth of fiber up to 18 gigabits per second, but maintain the electrical compatibility for the devices to actually talk to each other.
And that 18 gigs is crucial for uncompressed 4K at 60 Hz with full 4.4.4 chroma sampling.
And that chroma sampling number is really the differentiator here.
It is. A lot of long-distance solutions will compress the color data down to 4.2.0 just to save bandwidth.
Which is fine if you're watching a movie.
Sure, but if you are installing this in a boardroom or a control center with PCs connected, 4.2.0 makes text look completely blurry and fringy.
Oh, absolutely. It is a nightmare for Excel spreadsheets.
Yeah, it is. But this cable keeps the chroma at full resolution. And because the video is moving over light rather than electricity, you have zero attenuation.
Right. The signal at the display is mathematically identical to the signal at the source. Another thing I appreciate is how they handled the power.
Oh yeah, they 5 volts.
Right, since it is an active cable, it has a chipset embedded in the connector heads that needs juice, but it pulls that power directly from the HDMI source.
Which simplifies the rack build so much. You aren't hunting for an open USB port or trying to hide a wall wart behind a slim mount display.
Yep.
However, because it's active, integrators really have to remember that this cable is directional. You have a distinct source end and a display end.
So if you pull it through the wall backward,
it simply won't work. You get to do it all over again.
Well, speaking of pulling it through the wall, installation is where Kramer clearly listened to the people doing the work. Active cables have historically had bulky connector heads because they house the electronics.
And they always get stuck in the conduit, but Kramer solved this with detachable connectors.
Right, you can remove the standard HDMI shell, revealing a tiny micro HDMI connector underneath.
And they include this pull-through capsule that snaps right over that microhead. It protects the pins and gives you a pulling eyelet.
Which is massive for conduit fill ratios. The cable itself is only 3.4 millimeters in diameter.
That is significantly narrower than a standard shielded Cat6 Ethernet cable.
So if you're retrofitting a room and the conduit is stuffed with network lines, you can likely still fish this through. It has a tiny bend radius of 6 millimeters, so tight corners aren't an issue.
And since we're talking commercial spaces, we have to mention the jacket rating. It's a low smoke and halogen-free build.
Which is pretty much mandatory for public buildings in Europe now, and increasingly required for plenum spaces in the US.
Right. It drastically limits toxic emissions if there's a fire. Plus, that fiber core gives you total immunity to EMI and RFI interference.
So you can run it right alongside high-voltage power lines in a ceiling grid.
Without seeing a single artifact on the screen.
That is a huge troubleshooter right there. And on the audio side, it fully supports high bitrate formats like Dolby True HD and DTS HD Master Audio.
It passes everything through transparently. You aren't losing any fidelity.
And the build quality matches the price. 24-karat gold-plated connectors, corrosion resistance. The reviews really back it up too, sitting at a 4.7-star rating, with people constantly calling it excellent.
Because it's reliable. And in the AV world, reliability is really the only metric that matters.
So zooming out here, we're looking at a product that contains microchips, converts electricity to light and back again, and pulls power from the host device.
It definitely blurs the line between a cable and a piece of hardware.
It really does. Which leaves you with a fascinating question to chew on. As bandwidth requirements explode and we transition away from passive copper to active fiber optics, at what point do we stop calling these things cables and start treating them as complex electronic components?
I think we are already past that point. We just haven't updated our vocabulary yet. You aren't installing a wire anymore. You are installing a sophisticated component that just happens to be flexible.
A component that bridges the gap between our devices. Something to think about the next time you have to snake a line through a wall. Thanks for joining us on this deep dive.